Alright guys, so you've had a little bit to think about this. If this guy, Sage Kotzenberg, does a 1620 Japan Air, what does that 1620 mean?
Is that the degree?
That is the degree of his total rotation. So how could we figure out how many rotations that was?
Divided by 360.
Yeah, what is one rotation?
How come I know it's now?
Are you guys okay with that? Like if I were to do a trick and I'm like, boom, what'd I just do?
That's my 360.
Now, I've been snowboarding a few times. Guess how many times I've done a 360?
Once?
Never.
Zero? Come on,
So
why
could
would
you imagine doing a 1620? How many is that? Let's take 1620 and divide it by 360. And it is, what was that, Braylon? What does that mean? He did 4 complete spins and then a half spin.
So I was right 4 or 5.
So 4 or 5 somewhere, it's 4 and a half. Okay, that is nuts, okay? He was flying and he does 4 and a half. What would have happened if he did 4.75 rotations?
Then it wouldn't be a 1620.
It wouldn't. What would have happened to him, though, with his landing?
He would have fell.
Yeah, not cool. So you got to time those things. Good for him. All right, what we're going to be talking about today is rotations and angles and things like that. So we're going to start by just drawing angles and talking about angles and rotations, easy stuff like that. Then what we're going to do is talk about coterminal angles. So let's talk about this in general. We already said this. What is one rotation in degrees? So if I do a full rotation, what did I just do? 360. All right. Well, what if I only did half of that? What if I was facing you and now I'm facing away? What is that?
180.
180. So then what is a quarter rotation?
90.
Yeah. Now this one's not as obvious. What is 3/4 of a rotation?
Isn't it 45? Or something?
I want to say 30.
Is it 75?
No. Of a full rotation. So guys, what we're going to do to help with this is we're going to look at our XY plane again. And what we're going to do is we're going to start 0
270.
right here.
It's 270.
Now, let's
Is it?
go. Okay, cool. We're going to get to it together. So we're going to go around this way. This is how we're going to go. Okay, we're rotating this way. So, if we went all the way around, what did we just do?
360.
That gets us back to where we started, right? So these are at the same spot. Now, what did you guys say a half rotation is?
180.
And then a quarter rotation, we said was 90. So then, what would 3/4 of a rotation be?
Negative 90.
Yes, you don't know that yet, but pretend you don't know that yet. If I go 90 here, another 90 here, what do I need to go to get to there?
90.
Another 90. What's 180 plus 90?
70.
270. So this one is the trickiest for people to figure out. But what we're going to do is we're going to look at angles and we're going to split it into quarters. Now, does anyone know what we call these quarters?
Quadrants?
They are quadrants, because quad 4, right? Quadrants. Our first quadrant is going to be between 0 and 90, and we represent it with the Roman numeral 1. And what we're going to do is now rotate this all the way around. So then we're going counterclockwise, so 90 to 180 is quadrant 2. 180 to 270 is quadrant 3. And lastly, 270 to 360 is quadrant 4, and we write those with Roman numerals so it looks like that. Hopefully you can count 4 with Roman numerals. You good?
Just write 4 tallies.
So what we're going to do is we are going to talk about graphing angles, and we're going to then say what quadrant they're in, and then we'll talk about coterminal angles. And to be honest, it's a fairly simple day. Have you guys graphed angles before?
Yes.
Sounds familiar.
It should be somewhat familiar. You've done it before. Maybe you
Where
did it
use,
using
like, the
protractors.
paper, the graph, the thin secret paper.
Yeah, that was like a little protractor thing.
Yeah.
We're not going to use protractors, but that is a good way to do it. Okay, so we're going to start at the basics. So if you're like, I don't remember doing this, this is fine. what we're going to do is, when we're graphing, there's two sides to the angle. There's the initial side, this is where the angle starts. And then there's a terminal side, which is where it ends. Now, the initial side is always the positive x-axis. Or in other words, this piece right here. This is always the initial side.
So with the negative y-axis.
Well, the angle can go anywhere. And wherever we stop, that's the terminal side. So let's say I just did the terminal side here. So I'm going to put in there term for terminal. Now, our angle is going to be created by those two things, so that's the angle. Now, the letter we're going to use to represent is actually a Greek letter. Anyone know what this is called?
Oh, is it
Starts with the and ends in ta.
theta?
Theta.
The ta.
Good job. The ta, also known as theta. Okay?
I remember
We'll get to that. All right, now what I've just drawn, this is an angle in standard position, positive x-axis, and then we go to the terminal side. And it's normal for us that when we have a positive angle, we go counterclockwise like this. So over here by positive, I'm going to kind of show that I rotate counterclockwise.
Isn't theta like with sin and them? Like sin and
Sine,
Sine,
cosine.
sine and cosine?
Yes, we're going to use a lot of theta in the future. Now, guys, what happens if I put a negative with my angle?
It's opposite
Does
of
it go
positive.
clockwise?
There you go. Instead of going counterclockwise, we're going clockwise. So let's do some easy examples here, okay?
Okay. I like to know clockwise and counterclockwise.
Think of a clock.
Yeah.
And the
I
way
know,
the
but I
clock
feel like-
goes around is clockwise. And then the way that we're going to go with angles is counterclockwise like this. Have you seen Karate Kid?
Yeah.
Wax on, wax off. Right? No?
I have not
I
seen
know what
Okay.
you're talking about, you're not.
I know what
Alright.
you're talking about, but I haven't seen Friday.
Have you seen Cobra Kai on
Yeah,
Netflix?
I did too.
Alright, me and Eleanor are on the same page.
Yeah,
Everyone
we're
else
on
is
the
like,
same
whatever. Alright. Okay, here we go. 45 degrees. First question, if I go back and I look over here, which quadrant would that be between?
It'd be between the. it'd be
Wait, the
first
angle?
quadrant.
Yeah, if I'm doing 45 degrees, that's between 0 and 90.
So it would be the first quadrant.
So I'm going to start by drawing my initial side like this, positive x-axis. Now, how far into the first quadrant do I go? Well, this goes from 0 to 90. 45 is exactly half of 90. So I'm going to draw it kind of halfway up like this. And then I'll put a 45 degree symbol like that. So this is my angle, and it landed in the first quadrant. Okay, let's do some more practice, okay? Let's go to 255 degrees. When I graph 255, we always do the initial side on the positive x-axis.
It would be in the third quadrant between 180 and
All right. And if you're like not seeing that quite as quick, let's just go through this slowly together. So I want to start here. 255 is more than 90. It's more than 180, but it's not more than 270. So I want to go most of the way, but not all the way. And then this angle is 255 degrees.
So would the 255 be the circle part or the actual angle?
It's the angle created here, and we use this to kind of show that it's this way. Because we could connect it this other way, but that's not the way we went. We went this way.
I feel like the angle would be that littler one, though.
Well, you can get two angles using different routes. That's a good segue to our next one, but hold on one second.
Is that the negative 90?
Yes. All right, so guys, let's look now at negative 115.
We'd have to go clockwise because it's a negative.
There you go. So remember up here we said if it's negative, it's going clockwise. So I'm going to actually label this a little bit different. Here's 0. And then as I'm going this way, guys, so we're
Is that
going
quadrant 3?
this way. Hold on. I'm going to put this is negative 90.
And then negative 180 and then negative.
negative 270.
Oh,
and then negative
yes.
That's alright. Now, let's go through this. I'm going to do my positive x-axis stays the same. But I'm going to go negative 115. Is negative 115 more than negative 90?
Yes.
Yes, I'll be in the here. Does it go past negative 180?
No.
Nope. So what I'm going to do is I'm just going to show it going clockwise because it's negative. And it gets about, how much further is it than 90? It's about 25 more. So it gets in there a little bit like that. You don't have to draw it perfect. This is good enough. And which quadrant does that land in?
The second. Oh no, will we not label it different?
The labels are still the same. Good question.
Okay.
It's still 1, 2, 3, 4, whether you're positive or negative. So this lands in the third, and I forgot to write it in on the other one, but that other one landed in on the third as well.
Is this the other angle of that same angle?
No.
Oh yeah, because they'd equal 180 or something.
It would be, they're actually a little bit off. And I'll show you how to figure that out just now. Do you guys have any questions on graphing angles? Do you feel okay with this? Like the easiest part of your homework is this. It's like, here's an angle, graph it, which quadrant are you in? Can you do that on your own?
Yes.
I hope so. If not, come after school, I'll help you. Now we're going to talk about, today we're just angles and coterminal angles. So the next thing, which is actually the last thing we're going to talk about, is coterminal angles. Now coterminal angles have a prefix of co. So to help remember what that means, let's think of other words that start with co, like co-pilot, or co-captain, or co-founder. In all of those cases, what does it mean to be a co?
Like,
Assistant.
yeah, sort of.
Not quite, because if you have your co-pilot,
They're the same level though, like you share the leadership.
there you go. So they're sharing the leadership as co-captains or as co-pilots. Well, these coterminal angles, they share the terminal side. So when I think co, I think of sharing that responsibility, so they share the terminal side. So these are going to be angles that share the terminal side. A different way to think about it is that they land on the same spot.
It's like, yours is so much bigger. I have like tiny, like.
I know, do your best. Okay, so let me show you what I mean. Let's start by graphing 50. So Emma, can you help me with graphing 50? How would I graph that? Yep, got that, okay. Yeah, so it's in that first quadrant, because like I said, it's between 0 and 90. A little more than halfway. Does that seem about right? It's not perfect, but is that good enough?
Yes.
Okay, cool. So there's 50 degrees. Now, let's graph the other three angles here and see what happens. I'm going to go to 410. Now, how am I going to graph that? Well, we're going to start the same way here. Is this going to be more than 360? So that's more than a rotation, right? So I'm going to go all the way around once, which is 360. And how much is still left over once I've gone 360?
3, 6, 4, 10 minus 6, 90?
Let's do some math here. So if I
No.
do, trying to find a space to do math. 410 minus 360 is 50. So I've got one rotation, and then I go
It matches.
50, and look at that. Where does it land?
On the 50.
They're sharing the terminal side.
Why would you say 410 degrees?
Well, because if the snowboarder was doing a rotation, they want credit for that extra rotation,
Like
right?
50 degrees times 2.
There are other ways we could write it, but we'll learn that another time. Okay, now, Brian, what about 770? Is that more than one rotation? Yeah, is that more than two rotations?
Yeah.
What is two rotations? If 360 is one, what's two?
500. I knew that, but I forgot.
What I heard someone say it.
420.
No.
No.
It is 720. 36 plus 36 is 72, so 360 and 360 is 720. Is 770 more than 720? Yeah, so on this one, I'm actually going around twice, and how much is left over?
50? How do
50.
I know?
So, once again, we landed on the same spot with the 770. When they land on the same spot, what do we call them?
Coterminal angle.
Co-terminal angles. They're sharing that terminal side. Now, these three landed on the same spot going with positive rotations. Can we do that with negative? Sure, let's try it out.
But it doesn't make a full negative.
Yes, that's true. So if it's negative, it means we're going to be going clockwise now. And we're going to go past negative 90, we're going to go past negative 180, we're going to go past negative 270. And we're now going to go full rotation. How many degrees are we short of a full rotation?
50.
So this is going to come around like this, and guess where it lands? Right on that
50.
same spot. So
I
negative
get shocked every
310
time.
is a
When
co-terminal
we
angle
use
as well.
negative degrees besides like temperature. Like negative angle degrees.
In rotations.
Oh, is it
Well, I'm sure there's several other
real
ones. but-
life example?
Okay, come back to here. So here's what I'm going to do. I'm going to do this first example with you, but then I'm going to give you guys a chance to do two on your own. Now, I've included graphs here for reference, but you don't have to use them, but I'm going to show you how to use them. So your instructions say find a positive and negative coterminal angle for each angle listed right here. So I'm going to underline that. We want a positive and we want a negative. Okay? Now, I already graphed 45. It was right there. That's 45. I'm actually going to change colors for that. Hold on 1 second.
We just add and subtract.
Subtract what?
I'm not sure about subtracting, but
So guys, how did we get coterminal angles over here? What did we do? Instead of just doing 50, how was 410 different?
it was 360 plus 60.
There you go. We added on a full rotation, which is how many degrees? 360, right? Then to get to 770, we added on 2 rotations, which was how many degrees? All right. And then to get negative 310, we actually just subtracted off
I'm going to
360.
take this angle, it's going to spin 15 times.
You can do that if you want. But if I want a positive coterminal angle to 45 degrees, I'm going to say, well, you know what? Let's go around once and then land there. So that would be 45, but since I went around once in the positive direction, I would just be adding 360, which is 405,
Can I go around negatively twice?
if you want, sure.
Like negative?
I'm showing you the simplest way to do this, which is just adding and subtracting one rotation. So if I want to find a positive coterminal angle to 45, I just add 360. What if I want to find a negative coterminal angle to 45? What are we going to do, guys?
Minus 360?
So I'm going to do 45 minus 360. So what that's going to look like visually is it's going to be starting here, and we're going to go the other way and land on it. That's actually negative 315. So 405 is a positive coterminal angle to 45, and negative 315 is a negative coterminal angle to 45. Alright, now what I'm going to do is I'm going to pause for a second and let you guys have a chance to do this. What you're going to do is 255. You've actually already done 255. We did it on the last page. But I want you to find a positive and a negative coterminal angle. How do you get a positive? Add 360. How do you get a negative? Subtract 360. Do that for 255, and then when you're done, do it for negative 115. It's the same approach, even if it's negative. Go ahead. You got 2 minutes to try this out. And check your work with the buddy. if you need to use a calculator, you can use your phone, sure, or you can go grab a yellow one.